Morning, this is Ms. Billerbeck, and we are going to talk about 10.6 operations with functions. So if we have f plus g, that stands for f of x plus g of x. If we see f minus g, that stands for the function of x minus the function of g of x. And if we see f times g, that equals the function of functions f times g of x equals f of x times g of x. So let's see what all this means. So if I have f of x equals 15x squared minus 8x plus 4 and g of x is 11x plus 6, what is f plus g of x? So we're going to add these two functions together. So we have 15x squared minus 8x plus 4, and then we have g of x equals 11x plus 6. Now we need to be careful to only combine the like terms. If we have a square here, and this is a single exponent of a 1, which we don't normally write, we do not want to combine things that are unlike terms. So please be careful of that. So when we add this together, f plus g of x is 15x squared. Negative 8x plus 11x is plus 3x. And then we have 4 plus 6 is 10. So that would be f plus g of x. Now, it's very similar. F of x equals 15x squared minus 8x plus 4. And then we have g of x equals 11x plus 6. But this time we're going to subtract this whole equation from the other one when we do f minus g. So 15 minus 0 is just 15x squared. Negative 8x minus 11x, we'll write that down. 4 minus 6 looks like that. So now what we're going to write is the final line, 15x squared. Negative 8x minus 11x is negative 19x, and 4 minus 6 is minus 2. So for this one, we didn't have to do the middle step here. I just did it so that you could really understand what we're doing when we're subtracting the g of x from the f of x. So now we want to find the product of f and g. So, and then we want to look at domains. So we're going to multiply f and g of x. So f of x times g of x is just the square root, which we can write, well, we'll write the square root times 2x minus 1. Now we can write the square root like this. And then we're going to multiply that by the 2x. And then we have the square root of x times the 1. Okay, so this x has a 1 for an exponent. So we're going to add the x and the 1/2 plus 1, but we have the 2 in the front. So we're going to do add the x's together, and then this is just x to the 1/2. So what that's going to give us is 2x to the 3 halves minus x to the 1/2. And that would be our answer for that. All right, so now let's take a look at this one. So if we have 3x squared plus 4 times 2 to the x. So we'll distribute this to both. So we have 3x squared times 2 to the x plus 4 times 2 to the x. Now 4 is 2 squared. So we can write 3x squared. And actually, let's move this around here. So it's 3 times 2 to the x, and then x squared, plus 2 squared times 2 to the x. So now, if we remember our exponent laws, our final answer will be 3 to the 2 to the x times x squared plus 2, and let's put the x first, x plus 2. So that's what this one will look like. All right, so we had an opportunity to make their bases the same for this one, and we took it. All right, let's look at domain and range for this though. All right, so let me change this over. And we're going to put the plus 1 up here, or plus 2. Whoops, doesn't want to do it. So let me put, there we go. I'm going to put a parentheses there. We've got x, and then plus 2. There we go. So that's what we have written on the other page. Okay, so if we look at the red one, we see our domain starts at 0. So let's look at that, see how the domain starts at 0 and it includes 0. So we would have a bracket there for our domain. So domain will have a bracket at 0, and then it's going to go off to infinity. The range goes down to this point here at negative 0.27. So it includes negative 0.27, and then it goes off to positive infinity as well. And we put a parentheses. So let's look at the domain of this lower one, the blue one. Okay, so the domain is going off to infinity. It's all real numbers, basically. It's going from negative infinity to positive infinity. There's no restriction on the x's. On the y, however, it never meets with the x-axis, which is 0 on the y, and then it goes off to infinity. So it would have 2 parentheses around 0 and infinity for the range. All right, let's look at the last problem. So if you didn't catch that, here's the domain for the first graph of this and the domain for the second graph here, domain and range for the second graph. All right, let's look at the cylinder problem. So what are the dimensions of a cylinder without a top base?
Jillian and Caitlin, pause to the front office, please. Jillian and Caitlin to the front office with your things.
So we're going to separate this into 2 areas, this one. And this. Okay, so we have, what are the dimensions of a cylinder without a top base? So we don't have a top base here. If the outside of the surface area is 120 feet squared, and the radius, the height equals 2 radii. So the height of the cylinder is here. And then we have a radius here. All right, so our first area, the base area. So we have the area of the base is pi r squared. The lateral area, this blue lateral area, is the circumference, which is 2 pi r times the height. But the height is twice the radius. So we have 2 pi r times 2r, which gives us this lateral area, then is 4 pi r squared. So now we can add these two functions together. So if this is function of r, and this is g of r, if we want to do it like that, we're going to add the two functions together, f of r plus g of r. Okay, I'm just naming this area function this, and this area function that. So our total area would then just be f plus g equals, and we've got pi r squared plus 4 pi r squared. And then this equals 120 feet squared. So if we divide this by pi, which we're dividing both functions by pi, that leaves us with r squared plus 4r squared equals 120 feet squared divided by pi. Okay, so that gives us 5 pi. Let me grab another board here. So we have 5r squared equals 120 feet squared divided by pi. Now we're going to divide by 5, so we'll just divide by 5 pi. That cancels that out. And then we get r squared equals, and this is going to be 24 divided by pi feet squared. So we're going to take the square root. So r equals the square root of r squared, which equals the square root of 24 divided by pi feet squared. And that's going to give us the radius will be 2.76 feet. Since the height is twice the radius, that's 2 times 2.76 feet, which gives us 5.53 feet. So there you go. By adding the different functions to find what the lateral area, this area, plus this area of the one base equaling 120 feet squared, and we added those two functions together and set it equal to 120 feet squared, we were able to find the radius and the height. All right, that's it. Have a wonderful day. Bye-bye.